We're going to do two types of triangle. Here's the first type of triangle. It's right triangles. This whole chapter is about right triangles, okay? So we're going to deal with right triangles. Well, almost the whole chapter is about right triangles. Towards the end, it may not look like they're right triangles, but anyway. So this is a right triangle. Now, it's a special type of right triangle. In fact, this section right here is called special right triangles, if you want to jot that down. There's two types of special right triangles that we're going to deal with today. And here's one of them. Now watch. This side and this side are equal to each other. So that means this is an isosceles triangle. Well, if this is 90 degrees, tell me something about these other two angles. This is 90 degrees, and these two sides are equal to each other. It's called isosceles. Right, these two angles are going to be the same. Do you remember that from geometry? Okay, so if these two angles are exactly the same, then what are they going to be? 45, that's right. So that's 45 degrees, and so is that right there. So we call this a 45, 45, 90 triangle. Some people say 45, 45 right triangle. Same thing, isn't it? But I just say 45, 45, 90 triangle. Now, there's something special about the lengths of these. I'll just show them to you. I'm not going to go through the whole reasoning behind it. I could. In geometry, I would do that. But in here, I'm just going to show you something. Watch this. If I called this x, this is one of my legs. In fact, let's not call it x. Let's just call it leg right now. All right. So this is one of my legs of the triangle. This is the other leg of the triangle. Now, on a 45, 45, 90, both legs are exactly the same. All right. So if I know the value of this, then this one is exactly the same thing. So if I said this was 5, then what would this bottom length right here be? It would be 5. That's easy, right? It's the hypotenuse. This right here is the hypotenuse. The hypotenuse is always opposite the right angle. We're going to talk about the hypotenuse a lot here in the next few lessons. Well, at least this lesson anyway. The hypotenuse is always opposite the right angle, and there's a relationship between the hypotenuse and one of the legs. And let me just show it to you. So the hypotenuse is equal to the square root of 2 times one of the legs. Again, I could go through this and show you why this is true. Somehow I just don't think that it matters to you why. Since we're running out of time here, I just thought I'd just go show it to you. So this is important. You need to know this. It basically needs to be memorized. All right? That the hypotenuse is the square root of 2 times one of the legs. Well, now what in the world does that mean? Let's stick some numbers in here and see what's going on. Let's use that 5 like we said earlier. So if I gave you this side to be 5, let's find the other two sides. Let's find this bottom side and let's find the hypotenuse. Well, the easiest thing to do, and actually they're both pretty much just as easy, but I think the easiest one would be finding the other leg. So if this is 5, what's this other leg going to be equal to? 5. Now that's only true about what type of triangle? Isosceles or 45, 45, 90 triangle, okay? It's not true about every single right triangle. It's only true about a right triangle that has these two angles as 45 degrees, okay? Make sense? Or it's isosceles. Remember that word isosceles from geometry? That means the two sides are equal to each other, okay? Now we have to find the hypotenuse. Really, the hypotenuse is not that much more difficult. Look, the whole reason we take a whole entire section and talk about this, I could do Pythagorean Theorem, couldn't I? I could go 5 squared plus 5 squared equals c squared. Well, what's 5 squared? It's 25 plus another 25. That's 50, isn't it? So what's the square root of 50? Let's break that down. Well, it's 25 times 2, isn't it? What's the square root of 25? It's just 5, and then what? Square root of 2. So look, but did I have to go through that? No, because I know this thing right here. I know the hypotenuse is the square root of 2 times one of the legs. Isn't that true right here? This hypotenuse right here is one of the legs times the square root of 2. And I could have just done that in my head without doing all this stuff right here. Wouldn't you rather have a problem where you just look at it and say, oh, that's the answer, instead of having to go through all this mess? Yeah, absolutely. And that's why they show you these special triangles. Some people just refuse to learn the relationships between these, and they, well, I can always use Pythagorean Theorem. Yeah, you're right. You could always use Pythagorean Theorem. But it's just easier. It's quicker, right? If you're taking a test and it's a timed test and you want to finish, it's a lot easier looking at this and saying, oh yeah, the hypotenuse is the square root of 2 times one of these legs, 5 square root of 2, bang, I'm done. No work to even show. All right, you just write it down. That's it. Here's where it gets a little bit more complicated. What if they tell you the hypotenuse and you have to find one of the legs? So what if the hypotenuse is 5 square root of 2? Instead of taking the leg and multiplying to get to this, you're going to divide it. That's right. You're going to take this hypotenuse and do what to it? Divide it by what? The square root of 2. Because look, if I want to solve for one of the legs right here, how do I get the square root of 2 away from the leg? I divide it by the square root of 2. Do you see that? So it would be the hypotenuse divided by the square root of 2 equals one of the legs. Does that make any sense at all? Alright, so that's not too bad. So what if they gave you the hypotenuse as 5 square root of 2? It seems like an odd number, a weird number to give us, but sometimes they do that to make it a little easier for us. So it's actually kind of easy. So what's 5 square root of 2 divided by the square root of 2? That just cancels with that. What is it? It's 5, just like we thought it should be, right? So if they tell me the hypotenuse, I can always find this. Some people freak out when they give them the hypotenuse to be, with a square root. But it's actually a lot easier, because if it was just a regular whole number, this becomes a little bit more difficult. So let's change numbers. Let's say the hypotenuse was 7, and I wanted to find this leg. Now remember, if they tell you the hypotenuse, watch, you could plug it in here if you wanted to. 7 equals what? The square root of 2 times the leg. So how do I get leg by itself? Divide by the square root of 2. Agreed? See that? Just plug stuff into my little formula right here. So what is this? It's 7 divided by the square root of 2. A little bit of a problem leaving it like this. What's the problem? We talked about this. Yeah, you don't want a square root in the denominator. So do you remember how to get rid of that? Multiply the top and bottom by the square root of 2, just like this. Because really you're multiplying by 1, right? Didn't really change the value of it. So that's 7 square root of 2 over 2. So that's technically the better way to write this thing right here. So don't write it like this. Write it 7 square root of 2 over 2. What's this other leg going to be? Same exact thing, right? 7 square root of 2 over 2. Right, same exact thing. It's only true when it's a 45, 45, 90 triangle. Don't do that with other angles, okay? Because it won't be true. You got it? So if they give you the leg, how do you find the hypotenuse? Just tell me the step. What do I do? If they tell me the leg. Yes, you multiply by the square root of 2. Come on, it's right here in front of you guys. Has anybody been listening to me at all? Okay? If they give you the leg, you multiply it by square root of 2 to get the hypotenuse. Okay? If they give you the hypotenuse, what do you do to get the leg? Divide it by the square root of 2. Alright? Jot that down somewhere in your notes that makes sense to you. Alright? I think I've given you just about every scenario, every way to say it. You've got to write it down somewhere so that you remember how to get from one to the other. Alright? So that's only one thing we have to know with this, that the hypotenuse is the square root of 2 times one of the legs. We're going to do another one, though. Let's do this. Let's copy this triangle. Let's do another type of triangle. Let's stretch this out a little bit like that. Now, I don't know if this is to scale. It doesn't have to be. But it's still a right triangle. This time, this is not a 45-degree angle. That's going to be a 30-degree angle. So if this is 30 degrees, what's this angle up here going to be? This is going to be 60. So what do you think we call this triangle? 30, 60. Oops. I said 6 and I wrote 3. 30, 60, 90 triangle. All right? Because you got a 30, a 60, and a 90-degree angle inside your right triangle. Now, these two sides obviously are not equal to each other, are they? I don't know if you remember this, but from geometry we said this. If you have a triangle and you know all the angles inside of there, you can tell which side is the smallest side, which side is the biggest side. So if 30 is the smallest angle, the side opposite the 30 degree is going to be the smallest side. Okay? I call this the short side. Okay? Or actually, I'm talking about the two legs. This right here, this side right here is going to be what? It's opposite the 90. It's going to be the what? The hypotenuse, right? So this is always called the hypotenuse, okay? But I want to compare these other two legs of the right triangle. This is the short leg, and this is the long leg. Okay? You might remember this from geometry a couple years ago. All right? So this is the short leg. Now, how do you know it's the short leg? Just because it looks like it on your paper? No, because it's opposite the 30-degree angle. How do you know this is the longer leg? Because it's opposite the 60. This is the hypotenuse because it's opposite the right angle. Okay. Sometimes they're going to draw the picture, and it may look like it's isosceles, but they put a 30 here and a 60 here and a 90 here. All right. You've got to go by the numbers. Don't go just by what the picture looks like. I mean, I beat that into the heads of my geometry students. At least I try to. I don't know if it sticks or not, but at least I try to. That don't just go by the looks of the picture. Because if you remember taking the SAT, who took the SAT in here? Did everybody take it? Do you remember there were some pictures where, or some problems where it said it's not drawn to scale or something like that? Yeah. All right. So you can't just assume that the picture is what it says it is. You know what I mean? Or what it looks like it should be. Always go by the numbers. Always go by the numbers. Okay, enough of that. Now we have two things to learn about this. And the key is the short side. Both of these relate to the short side. The hypotenuse has a relationship with the short side, and the long side has a relationship with the short side. The short side is the key here. All right? So let's do the easiest one first. Which one I think is easiest? The hypotenuse. This is kind of interesting. As long as this is 30, 60, 90, the hypotenuse is exactly twice as big as the short side. It's double it, exactly 2 times the short side if it's 30, 60, 90. Doesn't matter how small your triangle is, how big your triangle is. Hypotenuse is always going to be twice as big as the short side. So I put 2 times the short side. Okay? I'm not going to go through any reasoning on why that's true. We could, but we're not going to in this course, okay? So just remember that it's twice the short side. So that's one thing. I said there's going to be 2 things to remember because I got a hypotenuse and I have a long side. So now the long side, this is kind of similar to that 45, 45, but it's not the square root of 2 this time. It's the square root of 3 times the short side. Now look, they both relate to the short side, don't they? The hypotenuse is twice the short side. The long side is the square root of 3 times the short side. So the short side is key, isn't it? All right, the short side is really what you want to find. That's the important part. So just remember that on a 30, 60, 90, the short side is the important side. I mean, they're all important, I guess. But I think in order to solve for these, the short side is what you really want to know. All right, memorize this. Know it. All right, get it to stick in your brain. I'm not going to write it down on a test or anything. You have to know these relationships. You good? All right, let's do a couple examples with this and we'll be done. Actually, let me grab this triangle. Make it a little bit smaller. I don't have to have it that big. All right. There's basically 3 different types of situations that you could have. All right, the easiest situation, I'm going to go from easiest to hardest, okay? The easiest situation is if they give you, now remember, this is 30, 60, 90. I don't want to forget that, okay? So it's a 30, 60, 90. I'm not making any assumptions. They tell me it's 30, 60, 90. So if they tell me the length of the short side, the rest is kind of easy. What's the first relationship that I said? The hypotenuse is what? 2 times the short side. So what's this hypotenuse? 6. Simple, isn't it? All right, just multiply it by 2. The long side's actually just as easy. For some reason, since there's a square root in there, people freak out over that. I wouldn't say freak out, but you know, it bothers them more. It's actually a little easier because I actually had to know my multiplication tables to multiply by 2. It's not that hard, okay, but you get the idea. What about this, though? This is the longer side because it's opposite the 60-degree angle. What's the relationship? That's right. It's the square root of 3 times the short side. So how do I write it? Just 3 square root of 3. Look, I really didn't even have to do any arithmetic with that. I just stuck the 3 next to a square root of 3. See why I said this side might be even a little easier? Because I actually had to know my multiplication tables to get that. With this one, I just stick a 3 next to a square root of 3. Boom, I'm done. So that's when I gave you what? The short side. Okay? So that's the easiest if I give you the short side. Let's just use the same triangle. I'll get rid of all this stuff. Here's the second easiest. This is probably almost just as easy. I'd say this is easy part B. All right, this is just as easy, I think. What if they told you the hypotenuse was 10? What do you think the short side? Right, find the short side. Remember, the short side is key here. So if they give you either one of these, always find the short side. So if this is 10, then this is going to be 5. Make sense? All right, because remember, this is twice as big as this, or this is half of this. Right? Either way you want to look at it. Now, once I know the short side, the long side's a piece of cake. What's the long side? That's it, 5 squared of 3. See how simple that is? That wasn't much harder, was it? A little bit, because you had to know to divide by 2 to get to this, but it wasn't that big of a deal. But the key was finding that short side. That's the first thing that I did. I saw the hypotenuse, and I'm like, okay, I got to find that short side, so I find that first. Make sense? All right, what do you think the other scenario is? Give the long side. That's right. Okay, so, I don't know, let's just say 7. So let's say the long side is 7. This is a little bit tougher, but it's kind of close to what we did in that 45, 45, 90 triangle. I'm going to write this down just so we can see it. Remember what the long side is? The long side is what? Square root of 3 times the short side. So what do I know? I know the long side. If you can't just do this in your head, plug it into this formula. I know the long side, so the long side is 7 equals square root of 3 times the short side. Now, how do I get the short side by itself? How do I get rid of that square root of 3 if it's being multiplied? I divide. Okay, I divide by the square root of 3, so I come over here and I divide by the square root of 3. That's right. Now I want to simplify it, though. All right. I mean, technically that's the number, okay? But for some reason, math teachers don't like you having it like this, and they want you to, they call it rationalizing the denominator. Okay, big fancy phrase for it. But how do we get rid of it? Yeah, square root of 3 top and bottom. So what do I get? 7 square root of 3 over what? 3. After a while, you'll start seeing this, excuse me, you'll start seeing this and just know to write it like this. It just becomes a pattern, right? Let's just try a random one. What do you think that is? What is it? 2 square root of 5 over 5. Right, exactly. So once you get used to it, it's not that big of a deal, is it? What do? You just stick that number up here and then just get rid of the square root on the bottom. Alright, however you want to think about it. You could go through this every time if you wanted to, but after a while you start seeing a little pattern developing and you're like, oh, instead of 7 divided by the square root of 3, it's what? 7 square root of 3 over 3. Make sense? That's why this is a little bit tougher, right? Because you have to divide by a square root. That obviously is a little harder than just multiplying by 2 or dividing by 2. Would you agree? Yeah. Now, once we know the short side, now I can find the hypotenuse. So what do I do to this to get to the hypotenuse? Times it by 2. And that's not hard to do. Times it by 2 over 1. So what do I multiply together? The 2 and the what? And the 7, which is 14. So what is it? 14 square root of 3 over 3. And there's your answers. They look kind of ugly, but they're exact answers. They're simplified answers. That's what a lot of math teachers want you to have, okay? Now look, if you're going into engineering or architecture or something where you actually use this stuff, you wouldn't write your answer 14 square root of 3 over 3. You'd stick it in a calculator and get a decimal approximation, okay? Because that's how you measure stuff. You won't go to a carpenter or somebody working on a house and say, hey Joe, what's the length of that? Oh, it's about 14 square root of 3 over 3. I'm like, okay, thanks. No, they wouldn't do that. They'd stick that into a calculator and they'd give you an actual number, okay, you know what I mean? But we're just talking about simplifying radicals and things like that. Later on, when you get into some real heavy-duty math, simplifying these radicals will help you out, will make things a little bit easier for you in the long run. And that's what they're basically trying to do right here. That's why they want you to do that. Is it a real practical, everyday way to write an answer? No, obviously not. Okay, putting this into a calculator, getting a decimal would be more practical, but we're just trying to get you to learn some things for later on, because when you have big, long math equations, sometimes it's a lot easier to work with this than a decimal, especially when it's not exact. Okay, does it make sense to you? That's it. Okay, that's all I got for you. It's not too bad, is it? Doesn't look bad here until you start working the problems. But all right, let me give you a worksheet and we'll be done.